Hello, in this lecture we'll find out the ratio between two radii. In drawing we have a big circle. Inside this big circle we have two smaller circles and also triangle ABC, the right triangle ABC that is partially located in the big circle. Angle ABC equals to 90 degrees. Line segment or side AB equals to 5 units in its length. Side BC of the right triangle equals to 12 units in its length. And we know that the radius of the small circle is equal to A and the radius of the big circle is equal to B. And our mission is to find out the ratio between the radii of those two circles, that is to say the ratio of B over A. Okay, so first of all we will implement the Pythagoras theorem on the right triangle ABC. Here by PT is the relation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square. And must be equal to AB square plus BC square. Repeat again. According to the Pythagoras theorem, the right triangle ABC, AC square equals to AB square plus BC square. So AC square equals to AB square. AB is 5, therefore AB square is 5 square, that is 25. Plus BC square, BC is 12, therefore BC square is 12 square, that is 144. So AC square equals to 25 plus 144 is 169. Here we take the root out of this equation and we get that AC equals to the square root of 169, that is 13. So we actually found out that the length of the hypotenuse AC of the rectangle ABC is equal to 13 units in its length, and we also know that AN equals to NC. That is to say, at point N, the hypotenuse AC is bisected into two halves. The first half is AN, and the second half is NC. So, AC over 2 is 13 over 2. The first half is AN, and the second half is NC. So we found out that AN equals to NC equals to 13 over 2. Each half equals to 13 over 2 units. So here the second half NC is equals to 13 over 2 units. Okay. In the next step, I will present to you a new rule and we'll implement the new rule in our drawing. According to the new rule, the radius of a circle that is blocked by a right triangle is equal to R, the radius R equals to A plus B minus C over 2. So here we have the right triangle ABC. Inside the right triangle ABC blocks this circle. The radius of this circle is R. According to rule number 8, you can find out the radius of this circle that is blocked by the right triangle ABC only by knowing the length of the sides of the right triangle ABC. Here, the length of side AB is A, side BC equals to B units in its step, and the hypotenuse AC, the length of the hypotenuse AC is equals to C units in its step, so the radius of this circle will be equal to A plus B minus C over 2. Okay, so we can actually implement rule number 8 in our drawing. So in our drawing we have the right triangle ABC. The right triangle ABC blocks this circle and the radius of this circle is A. According to rule number 8, the radius of this circle A will be equal to AB, that is 5, plus BC, that is 12, minus the length of the hypotenuse AC, that is 13, over 2. Repeat again. The radius A of the small circle will be equal to 5 plus 12 minus 13 over 2 according to rule number 8. 5 plus 12 is 17, so it is 17 minus 13 over 2. 17 minus 13 is 4, and 4 over 2 is 2. Finally, we found out that the radius of the small circle A is equal to 2 units. So we can write down here that A equals to 2 units. A equals to 2 units in its length. In the next step, here we have AB's tangent to the circle at this point. This is the point of tendency. We define the point of tendency as T, and then we define the center of this circle as P, and we join points P and T together by a straight line. P is the center of the circle, T is the point of the circle itself, therefore PT is the radius of this circle that is equal to A and A equals to 2. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. The radius PT is drawn to point P, the radius PT is drawn to point T, that is the point of tendency of tangent AB with this circle, and whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, according to rule number 1. find the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle that is equal to 2. The radius Pn is drawn to point N, that is the point of tendency of tangent BC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule number 1. Inside quadrilateral TPBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle. This fourth angle in total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle must be equal to 90 degrees. So inside quadrilateral TPBN we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral TPBN as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say TP equals to BN, but TP is 2, therefore BN must be also equal to 2. Likewise, in rectangle TPBN, Pn must be equal to TB. But Pn is 2, it is the radius of the circle, therefore TB must be also equal to 2. So here, BA or AB, it is equal to 5 units according to what is given us in the question. T equals to 2. So AB minus TB will be equal to AT. AB is 5, TB is 2, 5 minus 2, 5 minus 2 is 3. So conclusion found out that AT equals to 3 units in its length. We have the common external point, point A. From the common external point, point A, we have 2 tangents to the circle, tangent AT and tangent AM. And according to rule number 2, that the lengths of two tangents from common external point to a circle are equal, it means that AT equals to AM, but AT is 3, therefore AM must be also equal to 3. We have already found out that AN equals to 13 over 2. It is 1/2 of the hypotenuse that is equal to 13. So AN equals to 13 over 2. AN minus AM equals to MN. Again, AN minus AM equals to MN. I'll write it down. AN minus AM equals to MN. AN is 13 over 2, AM is 3, is equal to MN. So here we multiply 3 by 2 and then we divide it by 2 in order to account factor of 13 over 2. So 13 over 2, 3 times 2 is 6, so it is minus 6. So 13 over 6 is 7, and 7 over 2 is equals to Mn. So in conclusion, we found out that Mn equals to 7 over 2. Mn equals to 7 over 2. Mn, this line segment Mn, it is equals to 7 over 2. Okay. In the next step, I present to you a new rule, and you implement the new rule in our drawing. First of all, we define The center of the biggest circle is O. This is the center of the circle, of the biggest circle. That is O. And we have rule number 7. According to rule number 7, if a line segment that is drawn from the center of a circle bisects a chord, then the line segment is perpendicular to the chord. The center of this circle is here at point O. The line segment that is drawn from point O, that is the center of the circle, is OM. OM bisects chord AB. That is to say, AM equals to MB. So whenever you have a chord that is drawn from the center of the circle, in this case from point O, that bisects a chord, in this case OM bisects chord AB, that is to say AM equals to MB, it will be also perpendicular to the chord. That is to say OM is perpendicular to AB. It means that this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule number 7. You can implement rule number 7 in our drawing. We join points O and N together by a straight line. So ON exits from the center of the biggest circle, that is to say from point O, and it bisects chord AC. Why? Because AN equals to NC. And whenever you have a line segment from the center of a circle that bisects a chord, the line segment will be also perpendicular to the chord. That is to say, ON is also perpendicular to AC. That is to say, if ON is perpendicular to AC, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees, according to rule number 7. So, you can write here that ON is perpendicular to AC according to rule number 7. We define the center of this circle as Q. Q is the center of the circle, N is the point on the circle itself, therefore Qn is the radius of this circle that is equal to B. This line segment Qn is the radius of this circle. Point N is the point of tendency of tangent AC with this circle. The radius Qn is drawn to point N, that is the point of tendency of tangent AC with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius Qn. Again, tangent AC will be perpendicular to the radius Qn according to rule number 1. So we can find out that Qn is also perpendicular to AC. Qn is also perpendicular to tangent AC according to rule number 1. So, and from those two equations, ON is perpendicular to AC and Qn is perpendicular to AC. We will derive that point O, that is the center of the biggest circle, must be located on the radius QN. Again, point O must be located on the radius QN. I'll write it down. Point O, that is the center of the bigger circle, lie on the radius QN. If point O lie on the radius QN, it means that QON is one straight line. QON is one straight line. QON is one straight line. That is to say all the 3 points Q, O, and N, they are all located on the same straight line. So QON is one straight line. At this point, this circle touches the biggest circle. They are tangent to each other. At this point, we define the touching point of the two circles as U. And then we draw tangent VW, that is tangent to both circles at point U. This is tangent VW, that is tangent to both circles, the biggest circle and this circle, at point U. Point U is the point of tendency. Point Q is the center of this circle. Point U is the point of the circle itself, therefore QU is the radius of the circle that is equal to B, units in itself. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to QU, or QU is perpendicular to VW. So can I tell that QU, the radius QU is perpendicular to tangent VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself, therefore QU is the radius of the biggest circle that we define as X. The radius QU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. And whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius OU. Okay. OU is perpendicular to VW. Can I tell that the radius OU is also perpendicular to tangent VW. So, and from those two equations, QU is perpendicular to VW and OU is also perpendicular to W. We derive that OQU, line segment OQU is one straight line. the 3 points O, Q, and U, they are all located on the same straight line. Otherwise, if one of the points O, Q, and U are not located on the same straight line, then either OU will not be perpendicular to VW or QU will not be perpendicular to VW. So OQU is one straight line. So from one side we found out that OQU is one straight line. But from the other side we found out that QON is also one straight line. And from those two statements, we will derive that in total UN or UQN is one straight line, UQN is one straight line. If UQN is one straight line, it means that UN is a straight line. If UN is a straight line, this 9 second, UN is a straight line. UN touches the circle at points U and N. Therefore, UN is a chord that passes through point Q, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. So UN is the diameter of the circle. UN is the diameter of the circle. The radius of this circle equals to B units in time, and the diameter must be twice as long as the radius, therefore the diameter UN, that is the diameter of the circle, must be equal to 2B. UN, this line segment UN equals to 2B. Okay. The next step, we will join points O and P together by a straight line. Point O is the center of the biggest circle, point P is the center of this small circle. We actually joined the center of the biggest circle with the center of the smallest circle. The smallest circle touches the biggest circle at this point. We define the touching point as S. We have rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. The center of the big circle is 0 at point O, and the center of this small circle is 0 at point M. The straight line that connects the two centers together is OM. And according to this rule, rule number 9, the straight line OM must pass through point P, or OMP is one straight line. Again, according to rule number 9, OMP is one straight line. So I can implement rule number 9 in our drawing. The small circle touches the biggest circle here at point S. So those two circles have an internal notch between them at point S. Therefore, the third line that connects the two centers together, that is to say QP, must pass through point S. So QPS, again, the third line that connects their centers together is OP. The third line OP must pass through point S, that is to say OPS is one third line. So I can write down here that OPS, line segment OPS is one straight line this line segment OPS is one straight line. If OPS is one straight line, it means that here OP, this line segment OP, must be equal to SO, also SP again, SO, also SP equals to PO. I write it down. SO also SP equals to PO. What is the definition of line segment OS? O is the center of the biggest circle, S is the point of the biggest circle itself. This is exactly the definition for radius. So OS is the radius of the biggest circle that is equal to X according to our definition. So we substitute SO by X. What is the value of SP or PS? PS is the radius of this circle that is equal to 2. So we substitute PS or SP by 2. So we can only find out that PO equals to X minus 2. This line segment PO equals to X minus 2 units in its length. In the next step, we'll extend the perpendicular ON by a straight line and when you extend the straight line by a straight line, the result is a straight line. Therefore, OT is a straight line. If you focus on this side of the straight line OT at point N, here the sum of the angles must be equal to 90 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have this side of the straight line OT at point N, we have this angle that is equal to 90 degrees plus the missing angle, in total must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. It is given us the equation that AC is tangent to this circle at point M. Point M is the point of tendency. We join points P and M together by a straight line. P is the center of the circle, M is the point of the circle itself, therefore PM is the radius of the circle that is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with the circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, according to rule number 1, this angle must be equal to 90 degrees, and this angle must be also equal to 90 degrees. Okay, so we have here 1, 2 right angles. In the next step, we draw perpendicular on the radius MP at point P. Again, we draw perpendicular on the radius MP at point P. So actually, this angle equals to 90 degrees according to our construction. Inside quadrangle M and TP, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Okay, and we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle MNTP we have MP must be equal to NT, but MP is 2, therefore NT must be equal to 2. We define the length of side of line segment NO as H. Likewise, in rectangle MNTP, MN equals to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. In the next step, we implement the Pythagoras theorem on the right main triangle PTO. So copy the right main triangle PTO in a new page and implement on it the Pythagoras theorem. TO equals to 2 plus H. PT equals to 7 over 2. And we already found out that the hypotenuse BO equals to x over 2. In the triangle POT, according to the Pythagoras theorem, x minus 2 square equals to 2 plus h square plus 7 over 2 square. And open the brackets on both sides of the equation and you get that x minus 2 square equals to x square plus 4 minus 4x, and it is equals to 2 plus h square equals to 2 square, that is 4, plus h square plus 4h plus 7 over 2 square. 7 over 2 square equals to 49 over 4. In the next step, we will join points O and C together on a straight line. What is the definition of line segment OC? Point O is the center of the biggest circle. Point C is the point of the circle itself. Therefore, OC is the radius of the biggest circle that is equal to x. So I'll copy the right angle ONC in a new page and we'll implement on this right angle the Pythagoras theorem. ON equals to H according to our definition. And we already found out that NC equals to 13 over 2. So here this is the right angle ONC that I copied from the original drawing. According to the Pythagoras theorem, in the right angle ONC, X, here ON equals to H according to our definition. According to the Pythagoras theorem, on the right angle ONC, X squared equals to X squared plus 13 over 2 squared. 13 over 2 squared equals to 169 over 4. And concluding formula that X squared equals to H squared plus 169 over 4. Now we can substitute X squared in this equation by A squared plus 169 over 4. We'll do it now and we get that X squared X squared is 169 over 4 plus H squared plus 4 minus 4x equals to 4 plus H squared plus 4h minus 49 over 4. So here we have H squared on both sides of the equation, so H squared will get cancelled. We have also 4 on both sides of the equation, so 4 also will get cancelled. And we found out that 169 over 4 minus 4x equals to 4h it is plus 49 over 9 plus 49 over 9. Here we subtract 49 over 49 over 4. We subtract 49 over 4 from this equation and get that 169 minus 49 over 4 minus 4x equals to 4h. Here we add 4x to this equation and you get that 169 minus 49, it is 120, so it is 120 over 4 in total. That is equal to 4x plus 4h. So here we take a common factor of 4 for those two expressions. So inside the brackets we will have x plus h equals to 120 over 4 is 30. So 30 equals to 4 times x plus h. And divide this equation by 2 and we get that 30 over 2 is 15. 15 equals to 2 times x plus h. We divide this equation by 2 and finally we get that x plus h equals to 15 over 2. Again, x plus h equals to 15 over 2. What is the length of UN? We already found out that UN is the diameter of the circle, but UN is also equals to UO plus ON. That is to say UN equals to UO, that is X, plus ON, that is H. So in total UN equals to X plus H. So can I know that UN equals to X plus H? But we also found out that UN is the diameter of this circle. That is to say it is equals to 2b. 2 times the radius, 2b. And can I know that UN is also equals to 2b. It is the diameter of the circle. Show you here that we already found out that UN is the diameter of the circle that is equal to 2b. And from those two equations, UN equals to X plus H and UN equals to 2b, we derive that X plus H equals to 2b. But we already found out that x plus h, it is also equals to 15 over 2. So we can write here that x plus h is also equals to 15 over 2. And from this equation, 15 over 2 equals to x plus h equals to 2b, we derive that 2b equals to 15 over 2, or 15 over 2 equals to 2b. We divide this equation by 2 and finally we get that b equals to 15 over 2 over 2. That is to say b equals to 15 over 2 over 2 is 15 over 4. So the radius of this circle b equals to 15 over 4 units. And we have already found out that the radius of the small circle A, of this small circle A equals to 2 units. And therefore the ratio b over A, it is equals to b, that is 15 over 4 over A, that is 2. 15 over 4 over 2, it is 15 over 8. In terms of numbers, it is equal to 1.875 units. So B over A equals to either 15 over 8, so in the rest of numbers it is equals to 1.875. That is the answer to the question. In the next step I will summarize the lecture. In this lecture, I found out the ratio between the radius of this circle that is B and the radius of this circle that is A, or the ratio of B over A. So in the drawing we have a big circle. Inside this big circle we have those two small white circles. The radius of this circle is B, the radius of this circle is A. Inside this circle we have the right triangle ABC that is partially located inside the biggest circle. Angle ABC equals to 90 degrees, side BC equals to 12 units, side AB equals to 5 units. Our mission is to find out the ratio between the two radii, or the value of B over A. So first of all, we implemented the Pythagoras theorem on the right triangle ABC. According to the Pythagoras theorem on the right triangle ABC, AC squared equals to AB squared plus BC squared. I repeat again. The right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. So AC squared equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25, plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. So AC squared equals to 25 plus 144, that is 169. AC squared equals to 169. We took out of this equation, found out that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is equal to 13 units. At point N, the hypotenuse AC is bisected into two halves. The first half is AN, the second half is NC. That is to say, 13 over 2 will be equal to both AN and also to NC. A02 equals to 13 over 2, that is equal to AN and this is equal to NC. AN equals to NC equals to 13 over 2. Then I presented to you rule number 8 and implemented rule number 8 in our drawing. According to rule number 8, the radius of a circle that is blocked by a right triangle R equals to A plus B minus C over 2. You have the right triangle ABC, this angle ABC equals to 90 degrees, the length of side AB is A units, side BC equals to B units in the left, and the length of the hypotenuse AC is C. So according to rule number 8, we can know the radius of a circle R only by knowing the side lengths of the right triangle. Whenever you have a circle that is blocked by a right triangle, like in this drawing, we are able to know the value of the radius R only by knowing the side lengths of the right triangle ABC. That is to say, the radius will be equal to A plus B minus C over 2. So we can implement rule number 8 in our drawing. Here the right triangle ABC that blocks this circle. The radius of this circle is A. According to rule number 8, the radius A will be equal to AB plus BC minus AC over 2. Again, the radius A will be equal to AB, that is 5, plus BC, that is 12, minus AC, that is 13 over 2. Repeat again. According to rule number 8, the radius A will be equal to 5 plus 12 minus 14 over 2. 5 plus 12 is 17. So it is 17 minus 14 over 2. 17 minus 14 is 4, and 4 over 2 is 2. So I found out that the radius A of this circle equals to 2 units. Okay. Here, AB is tangent to this circle point T. The joint points, so point T is the point of tendency of tangent AB with this circle. We define the center of this circle as P. The joint points T and P together by straight line. Point P is the center of the circle, point T is the point of the circle itself, therefore PT is the radius of the circle that is equal to A, that is equal to 2 units. We have the radius PT that is drawn to point T, that is to say to the point of tendency. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius TP. If AB is perpendicular to TP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. Likewise, we define the point of tendency of tangent BC with this circle as N. We join points P and N together by a straight line. Pn is the radius of this circle. The radius Pn is drawn to point N. This is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius NP. If BC is perpendicular to NP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees, according to rule number 1. So inside quadrilateral TPBN, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, inside quadrilateral TPBN, we have 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square, so we relate to quadrilateral TPBN as a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, Pn equals to Tb, but Pn is 2, therefore Tb also is 2. Likewise, in rectangle TPBN, Tp equals to Bn, but Tp equals to 2, therefore Bn must be also equal to 2. So here Tb equals to 2, Ab equals to 5, therefore Ab minus Tb must be equal to 80. Ab is 5, Tb is 2, so AB minus TB is 5 minus 2, that is 3, so 80 equals to 3. And then we have rule number 2, that the lengths of two tangents from common standpoint to a circle are equal. From the common standpoint point A, we have two tangents to this circle, tangent AT and tangent AM. And according to rule number 2, they must be equal to each other. That is to say, AT equals to AM. But AT is 3, therefore AM must be also equal to 3. AN equals to 13 over 2, AM equals to 3, therefore AN minus AM must be equal to MN. I repeat again. AN minus AM equals to MN. AN is 13 over 2, AM is 3. So here, we multiplied 3 by 2 and then we divided by 2 in order to account factor with 15 over 2. So we have 13 minus 3 times 2 is 6, so it is 13 minus 6 over 2, that is 7 over 2. So in conclusion, found out that the length of this line segment MN is equal to 7 over 2. Okay, then we define the center of the biggest circle is O, and I present it to you rule number 8 rule number 7, according to rule number 7, if a line segment that is drawn from the center of a circle bisects the chord, then the line segment is perpendicular to the chord. The center of this circle is here at point O. From the center of this circle, we draw line segment OM. OM bisect chord AB. That is to say, AM equals to MB. And whenever you have a line segment that is drawn from the center of the circle, in this case point O, that bisect a chord, then the line segment OM must be also perpendicular to the chord. Here OM must be also perpendicular to AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. Again, because line segment OM bisect chord AB, that is to say, we know that AM equals to MB, therefore OM also is perpendicular to AB. This is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to this rule, rule number 7. So we implement rule number 7 in our drawing. We join points O and N together by a straight line. ON is a line segment that is drawn from the center of the biggest circle, that is to say, from point O, that bisect chord AC. That is to say, AN equals to NC, therefore according to rule number 7, ON is not only bisect chord AC, but it is also perpendicular to chord AC. ON perpendicular to AC, that is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 7. So in conclusion, you can say that ON is perpendicular to AC. ON is perpendicular to AC according to rule number 7. We define the center of this circle as Q. We join points Q and N together by a straight line. Point Q is the center of the circle, point N is the point of the circle itself, therefore Qn is the radius of this circle is equal to B. The radius Qn is drawn to point N, that is the point of tendency or tangent AC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius NQ. If AC is perpendicular to NQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. In conclusion, you can say that Qn is also perpendicular to AC. Qn, the radius Qn is also perpendicular to AC according to rule number 1. And from those two equations, ON perpendicular to AC and QN perpendicular to AC, we derive that point O lie on QN. Point O, that is the center of the biggest circle, lie on the radius QN. Okay, or QON is one straight line. QON is one straight line, that is to say, all the 3 points QO and N, they are all located on the same straight line. Repeat again. QON, line segment QON is one straight line. And then we have here, this circle touches the biggest circle at point U. Point U is the point of tendency between the two circles. We draw tangent BW, that is tangent to both circles at point U. Point Q is the center of the circle, point U is the point of the circle itself, therefore QU is the radius of this circle that is equal to B. The radius QU is drawn to point U, that is the point of tendency of tangent VW with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW must be perpendicular to the radius UQ. If VW is perpendicular to UQ, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So I can write down that QU is perpendicular to tangent VW. Likewise, point O is the center of the biggest circle. Point U is the point of the biggest circle itself. Therefore, OU is the radius of the biggest circle. The radius OU is drawn to point U, that is the point of tendency of tangent VW with the biggest circle. Whenever you have a radius that is drawn to the point of tendency, then tangent VW will be perpendicular to the radius UO. If VW is perpendicular to UO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So if I found out that UO, the radius UO, or OU is also perpendicular to tangent VW. And from these two equations, U is perpendicular to VW and OU is also perpendicular to VW. We derive that line segment OQU is one straight line. Again, line segment OQU is one straight line. And from the fact that line segment OQU is one straight line and line segment QON is also one straight line, on those two statements, we derive that in total UQN is one straight line. If UQN is one straight line, it means that UN is one straight line. If UN is one straight line, UN, the straight line UN touches the second point U and N. Therefore, UN is a chord that passes for point Q, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore, UN is the diameter of the circle. UN is the diameter of the circle, and we know that the diameter of any circle is twice as long as the radius. And the radius of this circle is V, therefore the diameter UN must be equal to 2B. UN equals to 2B. Then we joined points O and P together by a straight line. Point O is the center of the biggest circle. Point P is the center of the smallest circle. The smallest circle and the biggest circle have an internal arch between them, and this point was S. And we have also rule number 9. According to rule number 9, if two circles touch each other internally, then the straight line that connects their centers together passes for their touching point. The center of the big circle is at point O, the center of this small circle is there at point N. The straight line that connects their centers together is the straight line OM, and according to this rule number 9, the straight line OM must pass for point P. That is to say, OMP is one straight line. Again, OMP is one straight line. We can implement rule number 9 in our drawing because, again, we have the smallest circle touches the biggest circle at point S. That is to say, they have internal arch between them at point S. So the straight line, according to rule number 9, the straight line that connects their centers together is OP, must pass for point S. That is to say, OPS is one straight line. We can write here that OPS is one straight line. OPS is one straight line. If OPS is one straight line, it means that SO minus SP must be equal to PO. Again, SO once SP equals to PO. SO once SP equals to PO. What is the definition of line segment SO? You should remember that if SPO is one straight line, then SO must be also a straight line. SO is also a straight line. So point O is the center of the bigger circle. Point S is the point of the bigger circle itself. Therefore, OS is the radius of the bigger circle that is equal to X. So you can substitute OS by X minus SP. SP is the radius of this circle that is equal to 2. So you can substitute SP by 2. So in total you found out that PO equals to X minus 2. PO equals to X minus 2. Then we extended perpendicular ON and straight line until point T. When you extend a straight line by straight line, the result is a straight line, so OT is a straight line. So if you focus on this side of the straight line OT, point N, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have this side of OT at point N, we have this angle that is equal to 90 degrees plus the incident angle. In total, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. You know that AC is tangent to this second point M. Point M is the point of tendency. Joint points P and M together by a straight line. Point P is the center of the circle, point M is the point of the circle itself, therefore PM is the radius of the circle is equal to 2. The radius PM is drawn to point M, that is the point of tendency of tangent AC with this circle, and whenever you have a radius that is drawn to the point of tendency, then tangent AC will be perpendicular to the radius MP. If AC is perpendicular to MP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees. Okay, so we have 2 right angles inside quadrangle PM and T. And then we actually did the construction. We go perpendicular on MP at point P. Again, we go perpendicular on the radius MP at point P. So this angle equals 90 degrees according to our construction. So inside quadrangle MNPT we have 1, 2, 3 right angles, therefore the fourth angle must be equal to 90 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. Okay, so any quadrangle that does 4 right angles must be at least a rectangle if not a square, so we relate to quadrangle MN TP is a rectangle, and we know that the opposite sides of the rectangle are equal to each other. That is to say, MP equals to NT, but MP is 2, therefore NT must be also equal to 2. Likewise, MN must be equal to PT, but MN is 7 over 2, therefore PT must be also equal to 7 over 2. Then we define the length of ON as edge. So I copy the right angle POT in the new page and implemented of this right angle POT, the Pythagoras theorem. Here, we have already found out that PO or OP is x minus 2, therefore OP or PO is x minus 2, PT equals to 7 over 2, and here TO equals to 2 plus h. TO equals to 2 plus h, so according to the Pythagoras theorem and the right angle POT, this angle equals to 90 degrees, because of the fact this angle equals to 90 degrees, okay? According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. So in the right triangle POT, according to the Pythagoras theorem, x minus 2 squared equals to 2 plus h squared plus 7 over 2 squared. We open the brackets on both sides of the equation and found out that x minus 2 squared equals to x squared plus 4 minus 4x, that is equals to 2 plus h squared. 2 plus h squared equals to 2 squared, that is 4 plus h squared plus 4h plus 7 over 2 squared. 7 over 2 squared equals to 7 squared, that is 49 over 2 squared, that is 4. So 7 over 2 squared equals to 49 over 4. Then we join points O and C together by a set line. Point O is the center of the biggest circle. Point C is the point of the biggest circle itself. Therefore, C is the radius of the biggest circle, that is equal to x. In the beginning of the lecture, I found out that NC equals to 13 over 2 and H equals to H and O equals to H according to our definition. So we implemented the Pythagoras theorem on the right triangle O and C. On the right triangle O and C, according to the Pythagoras theorem, Q O C squared equals to O N squared plus N C squared. Repeat again. In the right triangle NCO, OC squared equals to ON squared plus NC squared. Okay, so OC squared is x squared, that is equal to ON squared, that is x squared, plus NC squared, that is 13 over 2 squared, that is 169 over 4. So in conclusion, we found out that x squared equals to h squared plus 169 over 4. Okay. Repeat again. The right triangle ONC. This is the right triangle ONC. X squared equals to h squared plus 13 over 2 squared is 169 over 4. Because of the fact that x squared equals to h squared plus 169 over 4, we can substitute x squared here by 169 by h squared plus 169 over 4. We did it and found out that, so here x squared is 169 over 4 plus h squared plus 4 minus 4x equals to 4 plus h squared plus 4h plus 49 over 4. We have h squared on both sides of the equation, so h squared will get cancelled. We also have 4 on both sides of the equation. Yes, so 4 also will get cancelled. We left only with 169 over 4 minus 4x equals to 4h plus 49 over 4. We subtracted 49 over 4 from this equation and found out that 169 minus 49 over 4 minus 4x equals to 4h. We added 4x to this equation, and we found out that 169 minus 49 is 120, so in total this expression equals to 120 over 4. That is equal to 4x plus 4h. We took 4 as a common factor for those two expressions and found out that 120 over 4 is 30, so 30 equals to 4. Inside the brackets we have x plus h. We divided this equation by 2 and found out that 13 over 2 is 15, so 15 equals to 4 over 2 is 2 times x plus h. Then we divided this equation by 2 and finally found out that x plus h equals to 15. X plus h equals to 15 over 2. Here, x plus h equals to 15 over 2. What is the length of un? Un equals to uo plus on. That is to say, un equals to uo, that is x, the radius of the biggest circle, plus on, that is h, according to our definition. So in total, un equals to x plus h. We can write here that un from one side equals to x plus h, but we already found out that un is the diameter of the circle that is equal to 2b. It again, we already found out that un equals to 2b. Here, un equals to 2b. So from one side un equals to 2b, from the other side un also equals to x plus h. So from those two equations we derive that x plus h equals to 2b. But we already found out that x plus h equals to 15 over 2. So we can write here that x plus h equals to 15 over 2. And from these equations 15 over 2 equals to x plus h equals to 2b, we derive that 15 over 2 equals to 2b. 15 over 2 equals to 2b. We divided this equation by 2 and finally found out that b equals to 15 over 2 over 2 is 15 over 4. So b equals to 15 over 4. And we have already found out that a equals to 2. And so b over a is b, that is 15 over 4 over a, that is 2. So b over a equals to 15 over 4 over 2. 15 over 4 over 2 is 15 over 8. So we found out that the ratio b over a equals to either 15 over 8, or in terms of numbers, it is equal to 1.875 without units. The ratio is without units. Again, b over a equals to either 15 over 8, or in terms of numbers, it equals to 1.875. Thank you very much.